We're going to go ahead and take a look at our 2.4 to 2.6 quiz review. For 1 and 2, the directions state the possible rational roots for each equation, then factor each. So for number 1, to state the possible rational roots, what we do is we find our factors of c. C are the factors of the constant, so of -4. So that's plus or minus 1, plus or minus 2, and plus or minus 4. D, those are the factors of the leading coefficient. So that's plus or minus 1 and plus or minus 5. So our possible rational roots, C over D, it's every combination of C and D. So 1 over 1, 1 over 5, 2 over 1, 2 over 5, 4 over 1, and 4 over 5. So those are our possibilities. Now, it says then factor each. We could go through and use synthetic division, but we do notice that this is a quadratic form function. So we are going to go ahead and try factoring this. And this, we have a 5x to the fourth, so we need a 5x squared and an x squared. This is a minus, so we need one positive and one negative, and then 4. So the factors of 4 are 1 and 4 and 2 and 2. It looks like we're going to want to do 4 here and a 1 here, because this will give us 5x squared and 4x squared. And we want to subtract those, so we want positive 5x squared and a negative 4x squared. So there they factor each, and really that's the factors. That we can't factor any further right now. We could solve these to solve for x, but it just asks for the factors. So the answer is there's C over D. Those are our possible rational roots, and then there are the factors. Next one, we'll do C and D again. So C, factors of 15, that's 1, 3, 5, and 15. D, the possible factors, or D are the factors of 2, so plus or minus 1 and plus or minus 2. C over D, we want all combinations of C over D. We don't have to repeat any if there are any repeats. Doesn't look like there are, so we have 1 over 1 and 1 over 2. So that's 1 over both of these. And then we'll do 3 over both of those. So 3 over 1, which we can just write 3, and then 3 over 2. Then we'll have 5 over both of those, so 5 over 1, plus or minus 5, 5 over 2, and then 15 over 1, and 15 over 2. So a lot of possibilities, but those are the possible rational roots. And then we want to go ahead and find a couple. We could do synthetic and try that, although we can also notice that for this one it looks like factoring by grouping will work out well. So I'm going to go ahead and rewrite this just so it's not all clumped up there. So 2x cubed minus 5x squared minus 6x plus 15. This negative 6x we change to plus a negative, because when we group we need to put that negative with the 6x. The reason I'm thinking this is factoring by grouping, because if we factor a common factor out, it looks like we'll have a 2x and a 5. So in the first one, we can factor out a x squared. If we factor out an x squared out of these two, we're left with 2x minus 5. In the next one, if we factor out a 3, we would get negative 2x plus 5, but we want to factor out a negative 3, which will give us 2x minus 5. As we discussed earlier, this is just a number. This is just a number. So I'm going to kind of say this strangely, but let's see if this helps. Is there anything in common in these two terms, in this and in this? Well, the highlight is in common, so we're going to factor out the highlight. So we're factoring out the highlight, because that's just a number. We're factoring out a number. It's the highlight. We're factoring that out. If we factor that out, what is left over? So if we factor this out, what's left over? Just an x squared. And if we factor the 2x minus 5 out, what's left here? A minus 3. So we factor out the highlight, and this is what was left over. We can't really factor any more within the integers or even rational numbers, so we're going to go ahead and stop there. Here is our factors. Next one, number 3, it says divide. Well, we can just use synthetic division here. We do the opposite of that, so that we're going to put a 2 out here. We list our coefficients. 4, there is no a squared term, so we have to make sure we put a 0. Then negative 25 and 27. We're doing this a little bit longer way, not the abbreviated way. So we have bring down the 4. 2 times 4 is 8. 0 plus 8 is 8. 2 times 8 is 16. Negative 25 plus 16 is negative 9. And 2 times negative 9 is negative 18. Add those together, we get 9. That is not 0. Actually, so it says divide. So our answer is going to be 4. We were an a cubed, so now we're at 4a squared plus 8a minus 9 with the remainder of 9. So we put plus 9 over what we were dividing by. So a minus 2. And that's the answer. All right, number 4. State if the given binomial is a factor of the given polynomial. Well, for it to be a factor, we can divide. And if the remainder is 0, then it's a factor. If the remainder is not 0, then it is not a factor. So we'll go ahead and do synthetic division again. We've got a 2, because we do the opposite of that. We list our coefficients, which are 1, 6. So there's 1, 6, negative 21, and 16. We bring down just 1. 2 times 1 is 2. Add those. 8. 2 times 8 is 16. Negative 21 and 16 is negative 5. And that's negative 10, which gives us 6. This is not 0. So state if the given binomial is a factor. No. b minus 2 is not a factor of that polynomial. Moving to the back page, write a polynomial function of least degree with integral coefficients that has the given zeros. You do not need to carry out the multiplication. So for number 5, it says the given zeros. So 2 is a 0, multiplicity 3. If 2 is a 0, well, let's write that we're going to have a function. Let's call it p of x. If 2 is a 0, that means x minus 2 is a factor. The multiplicity 3 tells us that it's going to be a factor 3 times. So you can put x minus 2 3 times, but it's better just to write x minus 2 to the third. Number 6, let's call this r of x. We want 5 to be a 0, which means x minus 5 is a factor. We want 2 to be a 0, negative 2 to be 0, which means x plus 2 is a factor. And for negative 3 to be a 0, we need x plus 3 as a factor. We don't need to multiply them out. We could, but we don't need to. The next two, 7 and 8, we use another theorem that we learned, the Conjugate Theorem, which states if there is an irrational 0 or an imaginary 0, then its conjugate will also be a 0. So as we look at number 7, we have -2. That's not irrational or imaginary, so we don't add any other zeros. But here we have -3 plus √2, which automatically means that -3 minus √2 is also going to be a 0. So let's call this f of x. If -2 is a 0, x plus 2 is a 0. If -3 plus √2 is a 0, I'm going to be careful here. We have x minus this number. So I'm going to put that in parentheses because the negative gets distributed. So x minus -3 plus √2 is a 0. And then if this is a 0, we have to have x minus that number. So x minus that number is one of our factors. We don't have to multiply this out, but we should simplify this. All those parentheses and negatives we can simplify. So we have x plus 2. The negative gets distributed here. So this will be x plus 3 minus √2. And then this negative also gets distributed, so this will be x plus 3 plus √2. And there is the answer for number 7. Our last one of this section. Let's call this g of x. G of x. If 0 is a 0, then x minus 0 is a 0, or is a factor. I'm sorry. Well, we don't really write x minus 0, so we would actually just put x. So anytime 0 is a root, x is a factor. -3i is a factor, which automatically means, so -3y was a 0, that automatically means positive 3i is a 0. So that is x plus 3i times x minus 3i. And that is our answer. We don't have to multiply that out. If you did, just for fun, you would end up getting x. We're going to leave that there. And then to multiply these two, this is going to be, it's kind of like an a plus b times a minus b. So it's going to be x squared minus 9i squared. But we know I squared is -1. So we have x times x squared. If I squared is -1, this whole thing will be positive 9. And then lastly, we could distribute that x and we get x cubed plus 9x. Number 9, a polynomial function with rational coefficients has the following zeros. Find all additional zeros. All right. Well, here is an imaginary number. Its conjugate also has to be a 0, so we would have -3 minus 3i. Here is an irrational number, so its conjugate would have to be a 0, and it's actually already listed as one of those zeros. So we don't have to write anything else. So the only other additional 0 in this case would be the -3 minus 3i. For 10 and 11, it says evaluate each function at the given value. Check your answer using the remainder theorem. Show your work. So it says evaluate, and then we're going to check using the remainder theorem. So essentially, we're going to do this two different ways. So evaluate just means we're going to plug in 2. So f of 2 is going to be 2 cubed plus 4 times 2 squared minus 15 times 2. 2 cubed is 8. 2 squared is 4 times 4 is 16. And then minus 30. That is 24 minus 30, which is negative 6. So f of 2 is negative 6. Then we want to check our answer using the remainder theorem, which states if we divide, and we're going to do synthetic division, the remainder will be the same as f of 2. So synthetic division, we'll put our 2 out here. We will list the coefficients. So 1, 4, negative 15, and we actually have to put a 0. So 1, 4, negative 15, and since there's not a constant there, we have to put a 0. We bring down the 1. 2 times 1 is 2. 4 plus 2 is 6. 2 times 6 is 12. Negative 15 plus 12 is negative 3. And 2 times 3 is negative 6. Negative 6 plus 0 is negative 6. And the remainder is the same as f of 2. Well, we're just going to do the same thing for number 11. We're going to do f of 4. This might be a little more involved here. Negative 2 times 4 to the 4th plus 8 times 4 cubed plus 6 times 4 squared minus 29 times 4 plus 25. All right, let's see how we do here. You can plug this all into your calculator and get the answer. We have negative 2 for the 4th is 256. For the 3rd is 64 is, oops, I put a plus sign. I mean an equal sign, I should put a plus sign. This is going to be 512 plus 4 squared is 16. 16 times 6 is 96. Minus 4 times 29. That's negative 116. And then plus 25. Well, let's finish this off. This is actually negative 512. So these become 0. We have 96 plus 25 is 121. So 121 minus 116 is 5. See how I did with my arithmetic there. Now we are going to do synthetic division to check that. So we're going to do 4 and list our coefficients. So we got negative 2, 8, 6, negative 29, and 25. We bring down the negative 2. 4 times negative 2 is negative 8. Add those together, we get 0. 4 times 0 is 0. 6 plus 0 is 6. 24. 4 times 6 is 24. Negative 29 plus 24 is negative 5. And 4 times negative 5 is negative 20. And we get 5. So in that case, it was actually much easier to do the synthetic division to find f of 4.